all? Hope you are all fine. Today, our lesson today is adding and subtracting radical expressions. To add and subtract any radical expression, we have many ideas here in this lesson, and we have a one vocabulary here, which is the like radicals. Like radicals, it is square root expressions with the same radicand. Radicand, it is the thing or the number or the variable which is under the square root or under the radical are examples of like radicals. It means that we must have similar radicals, like the following. Like radicals, like for example 2 radical 5 and 4 radical 5, the coefficients are different, but the root itself is the same. Okay, here and there. The next one, 6 radical x and negative 2 radical x. The coefficients are different, but the roots are exactly the same. The third one, as you can see here, 3 radical 40 and radical 40. Inside the root, this is exactly like that one. They must be exactly the same. Now, if the first one, 3 radical, for example, t, and the other one, radical 40, they are not the same. Move to the unlike radicals. Look at here. Look, 2 and radical 15. We don't have two similar radicals, so they are not like radicals. The next one, for example, look here. This is 6 radical x, while there it is radical 6x. Now look at the inside. Inside the root, we don't have similar terms. X and 6x are not the same. The third example, 3 radical 2 and 2 radical 3. Now, yes, the numbers are the same, but the radicals, which is the main thing here in this lesson, are not the same, so they are unlike radicals. Okay. How to add the like radicals, how to add the radicals in general, we will learn today how. Now, how to add 2 radical 5 and 4 radical 5. We simply add only the coefficients, the 2 and the 4. So we put it inside. This is 2 plus 4 radical 5, which is 6 radical 5. As you can see, we don't add the radicals. Be careful. We put it as it is, like exactly if we have x. If it is, for example, 2x and plus 4x, we will write 6x. Exactly here the same. We will write the root as it is. We don't change it, we don't add it, we don't subtract it. Only we add the coefficients, the 2 and the 4. For the next one, look here. 6 radical x minus 2 radical x. We only subtract the 6 and the 2 if and only if the roots are the same. The radicals are the same, and they are. So we subtract 6 minus 2 equal to 4, and we put the radical x as it is. Now look at the first example here, adding and subtracting square root expressions. Add or subtract. Look at the first one. Again, we have here 3 radical 7, 8 radical 7. The radicals are the same. So we only add the coefficients. 3 plus 8 is 11. Radical 7, we put it as it is. We don't do anything with the radical. Also here, 9 radical y and radical y. What is the coefficient here of radical y? It is, of course, 1, not 0. Be careful. It is not 0 radical y. It is 1 radical y. So we subtract 9 minus 1, which is 8 radical y. Okay, move to the next one. Now 12 radical 2 minus 4 radical 11. Obviously, here the two radicals are not the same. So we will write the answer as it is. We don't subtract. We can't subtract here. We can't combine the terms because they are unlike radicals. Here, unlike radicals. So we don't subtract. The answer is only like this. Now move to the next one. As you can see here, you have 3 radicals. 2 of them are the same, which is the blue one, this and that. Only the middle one, it is not a like term with them. So we only add the 2 like terms, which is -8 radical 3d plus 10 radical 3d. Here, of course, we will add the coefficients -8 and 10 to get 2, and we put the radical as it is, which is radical 3d plus 6 radical 2d. Now we can't combine these 2 terms because these here, unlike radicals 3d and 2d, are not the same in radicals. They must be exactly the same in everything again and again. Okay, the second example, simplifying before adding or subtracting. As we took before in the previous lesson, we took how to simplify the radical. Of course, radical 12 is not written in simplest form, and also radical 27. Now, radical 12 contains, or 12 contains, a perfect square number in its factors. What is the perfect square in its factors? It is the 4. Now 4 times 3 equal to 12. 4 is a perfect square one, while 3 is not a perfect square. Move to 27. 27 contains also a perfect square, which is 9 times 3. So we will now split the root to be square root of 4 times square root of 3 plus square root of 9 times square root of 3. Okay? Then we can find the radical for 4. Radical 4 is 2, and we write the radical 3 as it is. Here radical 9 is 3, and radical 3 as it is. We write it as it is. Now, since we have like radicals, the radicals are the same, square root of 3 is exactly as the same of square root of 3, so we simply add the coefficients. So 2 plus 3 is 5, and we put the radical for 3 as it is. Second and last example here. Again, we have 2 radicals. We must simplify them first. We have to find the perfect square in each one of them. 8 again, it contains a perfect square, which is 4. Now 8 is 4 times 2. 45 is 9 times 5. Be careful that we have to choose 2 numbers. One of them is a perfect square. For example, 45 also is 15 times 3. But we can't choose this choice or these factors. Why? Because none of these 2 numbers is a perfect square. So this can't be used in the radical. We have to choose a factor which is a perfect square, like the 9, which is here. Now split the root, square root of 3, square root of 4, square root of 2, plus square root of 9, square root of 5. 3 radical 4 is 2, here, and radical 9 is 3. Okay, of course we will multiply the 3 times 2 here. These are 2 numbers without any radical, free numbers, so we can multiply them easily, freely, to get 6, and the radical 2 will be as it is, will be written as it is. 3 radical 5 will be written as it is, 3 radical 5. Now in this step, we will look at the 2 radicals. We can see obviously that the 2 radicals are not the same. So can we add? Of course we can't add because these are unlike terms, and this will be the last simplified answer. Thank you for listening. Good luck and have a wonderful day. Thank you.